I'd like to thank you all for coming out. It's going to be a little code heavy, so I might get down into some Terraform details. So if you're not familiar, hopefully you can follow along from the slides and just get with me after and we can go into more detail. So who am I? JD Hollis. I've been doing software for about 15 years now professionally. These days I consult mostly with early stage startups, helping them on anything from strategy to operations, organizational design, product design, just kind of filling in gaps in whatever their knowledge or requirements are. And for the past year, I've been collaborating pretty closely with my client, New ID. So if this stuff is interesting to you, they are hiring. So catch up with me or Nolan, the CTO, out in the hallway. So what is Terraform, for those of you that don't know? It's basically an infrastructure as code tooling system. It's not indifferent from CloudFormation, where you declaratively specify what resources you want built in the cloud, and the system figures out how to build them in the right order for you. It also adds the capability of tracking remote state so that you can keep up with what's actually currently deployed and what's not, so that every time you apply, add new resources or alter the configuration, it will just automatically do the right thing most of the time. So what's the advantage of infrastructure as code? Well, if you're anything like me, when you were doing AWS to begin with, you were constantly poking around the AWS console and you can never quite remember what you'd actually done. That's fine for when you're just kind of playing around, but when you are trying to actually build production environments that are as closely mirrored to each other and scaling teams up and keeping everything in order, or even just auditing an environment, you need a little bit more rigor. On top of that, if you have to do everything manually every single time, it can be really time consuming, especially if you're using a lot of AWS resources. For instance, and we'll show in a minute here, one of our services has something like 6 SQS queues plus failure queues and all these different things that need to be wired up. If you had to do that manually, it'd be unmaintainable. So what were our goals going into this project in terms of the infrastructure? Well, the first thing we wanted to do was retain Ripple-driven development process. We're Clojure developers at the end of the day, and being able to work interactively is incredibly important, even if we are working with AWS resources. We also want to make it easy for developers to work with their own copies of a service. So in our definition of things, service is any combination of AWS resources that does one thing. So for instance, we have a front-end service that has an API gateway, has related lambdas, ions, et cetera. But we want to be able to do feature development on a branch-by-branch basis and still be able to test without developers stepping on each other. So to be able to do that, they've got to be able to spin up their own copy of that service and then whatever other related services they want to test against. We also want to simplify integration testing across environments. So instead of, it works on my machine or it works in dev and in the sandbox, we want it to be in such a way that you can actually guarantee that it's almost identical across all environments. And one of the nice things about that is that if it works in staging and you're keeping everything consistent, it's going to work in production. Assuming scaling issues don't come into play, right? And then, of course, we want to automate as much as possible. And that means everything from deployments. I don't want people to be able to push live to production ever. And what's nice about this is that we can, from day one, enforce good continuous integration, automated testing, and just in general, best practices. Plus, it's a hell of a lot easier. So for instance, it's not quite Heroku easy in that sense, but we're building things that are way more complex. So let's kind of take a tour through the system. And I might go a little fast through this, mostly because I'm not sure what level of detail you guys are interested in, but I want to leave plenty of time at the end for questions. So this is just a sketch of one of the systems we're building right now. As you can see in the center, we've got Datomic as a service, and then we've got a query group specific for this particular service, which in this case is the developer portal. And then there's obviously lots of boxes and arrows showing SQS, queues tied up to lambdas, et cetera. But really the general idea is that each service or application in Datomic terms gets its own query group, but we have a shared core storage and core compute with Datomic across multiple services. And some of the ways that comes in handy is that like not all of our services necessarily need a query group because they don't really need the read caching. So in those cases, we just fall back to a VPC endpoint and we're just kind of issuing transactions. We don't really care about speed in those cases because it's all offline. So how do we have the account set up? This is kind of becoming a little bit, or what seems to be standard, at least if you're starting fresh. So we have 4 AWS accounts and they're all completely isolated from each other. Like the dev is basically where our sandbox is. That's where anybody can spin anything up they want, play around. That's where you would probably deploy if you were going to do a pull request and needed somebody to come in and review the actual functionality. Stage is basically where we would do integration testing across different services. So, assuming it's made, like Stage is kind of the first place after you push to master that the code is going to go. And that's for, running your integration testing suite, your unit testing, and then also going through and doing whatever manual testing you might need to do. And then it goes to prod, hopefully. And between those two, there's actually a breakpoint where you can actually go and evaluate whether or not you want to push that through. And then we have the tools account, which is where we're maintaining our remote state. So it's kind of where Terraform sticks its state file to let you know what's done. And it's also where we store any kind of service that would spread across like all 3 accounts. So for instance, our core Datomic service, which we'll get into in a little bit, basically stores all dev stage and prod content in tools. This is a little bit different than the individual services, but the main reason is because we need to be able to read that at a more global level when we're deploying. So the pipeline looks roughly like this. We're using code pipeline primarily, which is a little bare bones, but for now it's actually meeting our purposes pretty well. And really what happens is like, at each stage we're trying to promote the actual artifacts. So for instance, in Terraform, there's always 2 stages. You always plan first, review the plan, and then apply. Really what we wanted here was to be able to have atomic applications of Terraform. So the nice thing about that is that if something changes underneath the state file for a plan, that plan will fail automatically because it no longer considers itself valid. So really what we want to do is that if there's something wrong, we want it to fail immediately before it actually applies any state changes. And then of course you would do your unit testing, or integration testing kind of wherever in this pile. So what does the Datomic core service look like? Well, so at the base level, we created just a module for a production topology. Previously, we did have a solo one that kind of faked a production topology by putting a useless load balancer in front of one instance, just so that we could take advantage of VPC endpoint and keep more consistency. But since then, we've decided to just kind of go with production topology across the board so that we can automatically have access to query groups and whatnot. And really, all we're doing is basically creating the same production topology across dev, stage, and prod. And if you're not familiar with the syntax, basically any directory in Terraform is considered a module, and then you can reference them and pass in inputs and get outputs out of them. So the top of really all we're doing is wrapping like the Datomic compute and Datomic storage CloudFormation stacks. So unfortunately, you still have to manually go in and create your initial stacks through the AWS Marketplace. That's probably the biggest friction in working with this. It's not that bad because typically you're not going to be doing it that often. But it's a little irritating. The nice thing is CloudFormation makes its outputs through Terraform very easy to get to. So this allows us to pull out everything that we would need for either configuring IAM permissions or wiring up different pieces of VPC networking. So once we have all those datas, then we're going to go ahead and get our inbound Bastion rule set up, and also a VPC endpoint service. And then we also have an SQS VPC endpoint because we're using that pretty heavily with some of ours. And that way you don't have to get into the VPC too heavily. Because there's a lot of different ways you can wire things up, but some of them are way more intrusive than others. This tends to be a little tidier. And besides that, that's pretty much it for that module because obviously the CloudFormation already did everything for us. So really then it's just extracting which outputs we want from that so that we can feed those into other services that are going to query this. So kind of the approach we've taken is a pull instead of just publishing everything. It's basically when we come across something that we actually need, we toss it in there. That's kind of kept it relatively small, but over time, the list of outputs has actually grown quite a bit. So the way this rolls up to the top level of the module is that we're then publishing each one of these outputs to the different accounts. And keep in mind, each one of these, and that's something I can go back and look at for a second here. You notice the profile is set differently. So what we end up having for our setup is we have an ops profile, which is basically an administrator account. And then we can assign the ops role in the different environments. So ops dev would be ops and dev. So there's a lot of assume role magic in here. But the point being is that this creates these in each separate account. And then we roll it up to the outputs so that for the top level module. So that way, if we're in dev, we're going to only be querying the dev outputs for that Datomic system. Otherwise, if it tried to query stage, it wouldn't work, obviously. So in terms of setting up the query group, and so actually, and I'll go ahead and state this early too, if you're not used to thinking about or using Datomic in this way, this could seem kind of pricey because we're going to have a lot of compute resource running, whether or not we need it. Now, in this case, we've made a decision that it's worth having the consistency between the environments to have this and to have the additional isolation. So a query group is basically a way to deploy particular application code to your Datomic system as local caching and whatnot. The nice thing about it is that if you no longer need a particular service or application, you spin the whole thing down and the rest of your system just continues on as normal. So this allows us to basically deploy multiple ions or different things that are without having any crossover between the services. Outside of, obviously, they have to interact with the transactor eventually. So our query group module looks roughly like this. It's this kind of the standard, and I'll send a link later because I've created a kind of a starter template on GitHub. But really, it's a lot of shell scripting at the end of the day. And really most of what this is doing is, and we're going to go in more depth here, it's creating the query group and then creating whatever IAM profiles or additional resources that you would need to pass in. And we pretty much have the same module in every project, and then it'll evolve from there, because obviously you have different ions and whatnot. We try to keep the same layout though, just for consistency, so that if you pull up one service, you're going to pretty much know where to go look for your node profiles, for instance. So remote state, this is what a query for that would look like. In this case, we're using the S3 backend. It's all encrypted at rest in the tools environment. And really the theory behind that is that somebody may have access as a developer to dev, but they don't necessarily need access to this except just to query this. So we can really lock down everything from permissions wise to make sure that only the services that need to query this data have access to the actual state file on S3. And from there, we can actually query what we need to inject into the query group. So this is what creating a CloudFormation stack looks like. It actually worked better than I expected, even when you need to upgrade your stack. You just update the template URL and it will do the right thing. Which is one of the nice things about Terraform is in general, it tends to get updates faster than CloudFormation. And they're usually using the straight APIs underneath. So it ends up being very stable and performant. And really what we're doing here is creating the application, creating the environment map, injecting whatever resources we'll need from our environment variables. The instance type, of course, is configurable, and you can also adjust any other additional parameters that the query group stack supports. Now, this is where it gets a little weird. So typically in Terraform, every resource is represented as an actual resource. But occasionally you need to run code that basically you need a side effect, essentially. So at the end of the day, we have this thing called a null resource. And what you can do is configure it to run arbitrary commands. They have multiple provisioners. I think they have a chef provisioner and a puppet provisioner. But in this case, we're just running a release command to compile and push up the Datomic ions. Now I've got a little bit of a different behavior based on whether it's in dev or whether we're pushing a stage in prod. And that's really has more to do with how we're injecting AWS credentials at each stage so that it just works. Now this is a little messy. I'm not sure, it's kind of hacky. I'm not sure I actually like this for long term. But one of the things if we go back to this, we're looking at, you see the triggers call. And the main thing with the triggers call is to basically make sure that, that this gets redeployed whenever there's an actual change that's relevant. So either one of the ions of the source code's actually changed, or the query group itself has changed. So for instance, if you've just updated to the new stack, you need this to redeploy. So that's how we kind of rig that up there. Longer term, I would like something maybe more Git related, or something a little more elegant. But for now, this works. So the other thing that gets weird about dependencies with Terraform is that most of if it's got the AWS resources, it knows how to calculate the dependency graph. So if it usually knows that, okay, I need this before this. But whenever we're dealing with things that happen outside of there, such as deploying ions to a cluster, we need some other way to signal back to Terraform that all this has to happen first. And so one of the ways we're doing that here is, first of all, of course, we're depending on the CloudFormation stack explicitly. But that actually doesn't always work because maybe the stack is complete, but we're still spinning up the auto-scaling groups. So that's why we're adding the extra auto-scaling group query to force that to be completely done before Terraform tries to deploy ions to it, for instance. And then again, we've got the usual outputs. The bottom output's actually kind of a little weird. So in Terraform, there's no real way to depend on modules as a whole. Like you can't say depends on module dot query group because it doesn't really know what defining feature of that would qualify as like an ID or whatever. So one of the ways we get around that is we actually depend explicitly on like the null resource to make sure the ions were deployed. Now that because as you're going to see in a minute, we're going to need to query against that. So with a null resource, the ID changes every single run. So that way it's always going to trigger a change here. So what does ion deployment look like? Well, so you see the scripts there. I mean, honestly, it's not that different from like what Datomic has actually in the documentation. The biggest difference is that we can't really be asynchronous with our deployments. We've got, for those releases, we need this to happen synchronously, and we need to know it's completely done before Terraform can move on. So really what we've done is built some shell scripting. Now there's some extra magic in there for creating a suffix, and that's really the goal there is just to make sure that we've got unique resources so that if 15 people are deploying to different branches to dev, we're not stepping all over each other. We've got some other tricks around that later on. But really the only complication here is that we've got to assume our particular ops role because we can't just deploy as the regular ops because of course that's kept in an entirely separate account. So really, like all these scripts are doing is making sure we inject the credentials correctly, make sure we assume the proper role, so that the ions get deployed to the right place. And so then this would be what the code build version of it would look like. So in the code pipeline, obviously we've got a simpler role story because we're injecting the assume role ARN, but we still have to parse it to make sure that it's there for the bottom. And at the bottom, all we're doing is running, a closure dev release. Now, and we'll get into this in a second, you can tell that like the basic CLI tooling for Datomic wasn't really built for automated deployments. That's something I'm kind of hoping that they'll be able to like improve over time. But we kind of found a way to hack around it. And this is the approach. So we ended up basically using undocumented APIs. I know it's a terrible thing to do. I would argue they should probably be documented because of this exact application. But maybe I just need to put in a support ticket. But really all we're doing here is basically doing the same thing we would ordinarily do with push and deploy, but then we're waiting to see that the status comes up the way we want. Now, there's a couple of issues with like the CLI tooling baseline is that first of all, like Eden is great when you're at the REPL and it's great when you're in closure. But if you're in Bash, it's basically useless. And then also if you don't have the proper signaling on like system exit for what Terraform expects, it's not gonna be able to like know that, it either errored out or it actually worked. So all we do at the next level down is check for it succeeded and then we either exit 0 or we exit 1. So sometimes this can be a little slow to watch, But unfortunately, it has to be synchronous just to make sure that we get through, so that Terraform knows that the ion code exists. So how do we integrate this with the larger services? So the query group is basically the module, I'm saying like sources Datomic, is what I kind of showed you at the very beginning. So really we're just injecting whatever we need in here. Like we have certain standard things that we're always injecting. So assume role ARN is how we make sure that we're using the correct deployer roles and different things in different places so that the right permissions are there. And I'll tell you, anybody who's used IAM, that's probably the most work involved with a lot of this stuff is locking down the permissions and making sure they're as minimal as possible, even for deployments. And that it's gotten easier over, like they're getting better feedback, but it can be a lot of trial and error to actually sit there and go, oh, that one doesn't take a star. That's a problem. But overall, the old goal is to try to create resources that we need, such as like SQS queues at a top level. And actually, I didn't really go into this, but kind of the way I'm telling this story is sort of inside out. Typically, when we build out Terraform modules, we always start with the innermost module and work outward. This ends up being really nice in, say, like IntelliJ, for instance, where it's got really good feedback on where variables are missing. So that by the time you get out to this query group module declaration, like IntelliJ will just fill in the blanks for you, and you don't really have to do a whole lot of extra work there. And it can also help you see where the gaps are. And so again, we also have outputs coming in to these different things. And some of these are used in part of the tooling, it just kind of depends on the application. Like you might have some standard ones like this for every application, but you might have some additional weird ones too, depending. So all of this, what this really does is get us to the ability to query the Lambda functions that Datomic created. And of course, we want to make sure it's dependent on that IONS output, so that we don't try and wire it up to something before the Lambda is fully deployed. And it ends up being, pretty tidy. I'll get into something that's a little weird. The permissions for the AWS Lambda function can actually be different than the actual node permissions, which I've only run into really with trying to wire SQS up to Lambdas. But it's just something to keep an eye on, is that sometimes the way the Lambda is invoked is going to be different than what you would actually, when it passes through to the actual nodes in the query group. So let's go through some Terraform tooling. So, seeing a lot of this really nasty bash scripting, and really what this is just making it really easy to figure out or to create unique branches. Now or create unique named resources. So there's a lot of resources in AWS that have to have new names or different names. It could be a little bit of a hassle down the road because, if your branch name is really long, like some of mine are, there's resources that'll have like a hard limit of like 64 characters. Usually I just try and hack around that when it comes up. But one of the ways that you can get around that too is we've just added is the ability to put like a dot suffix file. This is also nice too, where if you're committing a lot to a feature branch, but you don't want to have to spin up a new query group just because the name changed. You can just kind of keep more consistency between your deployments when you're in development. We're also, overriding the backend variables for dev. That's really just to kind of help configure Terraform so that it's going to, your unique state file and not someone else's. Well, and the other point here is that also, so we really, the only two custom scripts are for init, which sets up the backend, makes sure the remote state's where it needs to be. And then actually the plan file. Because once the plan runs, everything's already locked down into the plan file. So the nice thing here is that we've got one of our standard dev.tfvars, and we have a same thing for stage and prod. And really that would be changing things like the database name that you're trying to create, different things like that. But we have the ability to override with user because sometimes I want to be working in my database, Nolan needs to be working in his. But we don't really want to tie that to the Git revision because you may be using the same database across multiple deployments. And so all that code is actually up in the Datomic service in Datomic Terraform examples. There's also pipeline example on how we're doing our automated pipelines. I didn't really go into that as much just because it's going to be so specific to your application that I'm not sure how useful that is. And then I also did an SQS-driven ION just so you can see ways to wire up existing AWS infrastructure to the ions. That was kind of quick, but does anybody got any questions?